Hi, I'm Margalit. I'm the CTO and co-founder of Noobaa. So let's start with the client. Okay. So take an application talking S3 API, HTTP, right? So you have to get some kind of backend for that HTTP server, which is part of our what Yuval described as a RESTful server, right? So an S3 endpoint server. I hope it's big enough. And so writing to that endpoint basically means you're sending some information, right? You're saying, well, I'm going to write this bucket and key, like a namespace indicator. I'm going to send like custom metadata, whatever it is interesting for the later retrieval. And you're sending, of course, a data stream, and I'm missing some authentication, of course. So you got some information on your request, right? And that's all the API for S3. So coming back here, so each request can be served by a completely different server in that case. So you can basically take that and scale it up as many CPUs you can find wherever you get it. So it doesn't really matter. You just can scale that, just load balance between these. Either DNS load balancing is easy to do, or inside a single machine, of course, you can load balance inside. Okay? So you get each request being served by CPU, and I'll show you why it's important, because now we're going to do an ingest path, which is pretty heavy for that. We want a value of this ingest path.
But the HTTP load balancer is the responsibility of the customer. You don't build it in.
So if you inside a certain machine, of course, we do that. So our software is doing that. So you can utilize all the CPUs of a machine for that, if you want to put that on a machine. Inside our server as well. So once we deliver the core server that you put on your the first brain, so you get that as well.
Right, but across multiple machines.
Yeah. So one thing we're seeing, which is very interesting, is basically attaching that to the client, to the application, which means that basically that's like a local host access for that, and it's like a driver in that sense, right? So if that makes sense for applications, that makes sense for that, because you can take it anywhere. It's a cross-platform package. You can do that anywhere, and then you don't really need that, and you get your performance locally, right? If you can spare the CPU here, that's the point. If not, yeah, you need endpoints to install them, and we're handling that. So like you see in the nodes, we want to make it easy to manage them and see what you got, how to use them, etc. And HTTP also has redirects that can help. So now let's go to the pipeline. So data is coming on that stream, right? And we pipeline that. And I'll just highlight the points which Yuval said before. So first we do chunking. Second we do hash, so a SHA calculation for dedupe. Compress and encrypt. So I don't know if you're interested in details. This is Rabin chunking. This is SHA, fast one. So we picked the fastest ones because we want the value. We don't want to be overloading everything about it. We want it to be a high performance. So this is snappy. Of course, everything can be changed here. And encryption, AES, GCM, whatever. So that process ends when you have like chunks encrypted. You have information about the data, checksum, and everything else. And next point, what actually we're doing, right? We're communicating this metadata. So we have in the component in our core server, the metadata server inside service. Sorry. I hope it's big enough. And what we're sending over, so we're batching this. So we take as many as we can and send as a batch to the server to look up the hashes. So we want to dedupe as much as we can, right? So we have like a 0.5 megabyte on average here of chunks. And we're looking up these SHA checksums. So
just to highlight one point, we're not communicating with the metadata server the data.
Yeah.
We're just communicating the metadata.
Sure.
Okay. So only in our case, it's less than 1% of the data is metadata. So most of it still is not being communicated here. We'll show you what we do with that.
Sure. Yeah. And right, if you finally dupe, then you're done. Data just drops here. You don't need to do anything about it. Just map it inside. And for when you don't have, basically what we do is we need to allocate, and that's an interesting process. we need to allocate some nodes. We need to allocate the nodes for that request. And let me try now to open a new one, because that's a big process that we're.
Can we
Peel from the top.
Yeah.
Peel
Can we assume before you go that way, guy? Can we assume? No, don't peel.
Yeah.
Can we assume that the nodes were allocated just for now?
Yeah. So let's close the loop here.
Nodes was allocated in magic, but we'll show you the magic.
Sure. So right here we get the next step. Next step will be to write out the data to the nodes that were allocated. I'll show you exactly what it means in a second. And as a last point, we basically say, well, that was finalized. So so that part. All of these chunks here were basically allocated, written correctly, and I'll show you what it means. Well, I want to go through allocated nodes now because I think there's not much here to cover actually before you understand different policies and allocations.
Just to highlight one point, when you do the write-out is down directly between the S3 endpoint and the nodes. Okay, so this is where the data goes by peer-to-peer. We write first to the local nodes. We provide a list of nodes, and you write first to the local nodes, and then replication. This is part of how do we deal with not basically bombing the network anywhere, but rather writing locally, propagate the data, and then move it to the other side if needed by one move. Okay?
Is there a defined maximum of
Sticky.
objects that the system can handle, or experienced maximum? You know.
No,
right.
we've not hit it yet. We can drill down into. Oh, nice.
Yeah.
We can drill down into metadata management, but that's 2 hours on its own.
Sure.
We've not identified any.
Okay.
Okay, so I think through the process of allocating nodes, you'll see you'll see how write will work, and you'll get the full view. So basically, we got a bucket, right? We know, as you've seen before, we have a policy for that bucket, right? So we have a placement policy, and let me try and show you a placement policy that looks like that, and show you how it works. So let's say it's mirrored between two pools, so pool A and pool B, sorry, and the cloud, like we had in the example in the demo, right? So basically, we want to put 3 copies here, right? 3 here and 1 here. That's what we're doing.
And A and B, as an example, could be data centers. This is the easy way to think about it. So I have 2 data centers. I want to keep a primary and DR. We're not. So A is the primary, B is the DR, and C is the cloud.
Sure. So let me just, what we want to do is basically take all the considerations we can take, right? We want to make it as the smartest decision we can do to allocate. And once we do, the behavior of this path will be, so let's say we'll pick this one as the first target. We will later do a sync mirroring and so move copies, so create more copies as a sync mirroring and not do that. So the client, so the endpoint will only need to write like a single pool copy, or 3 copies, right? But I'll show you how it's effective as well. So we need to basically decide where we're going to start, right? So we're going to start by saying what do we know. So something we want to provide is locality. So the endpoint we allow to do is basically set for each endpoint as well to tag that it was a pool. And then say, well, the locality of this endpoint should consider this pool as local. And then when you have that information, you can actually choose, for example, pool B as the first one to work with, right? And now let's go and see what else we have. We collect a lot of information from the node. So we monitor nodes constantly. We know exactly about their availability and performance, both disk and network. Capacity, of course, and usage. So as the example before, that we want to keep some buffer for the applications running there. So if it's growing too much, we want to shrink our usage, right?
CPU, memory.
Yeah. So everything we can collect like as a user space application in that node is a factor that we want to take into consideration when we pick. So this pool can have like 1,000 nodes, right? So we want to pick the ones that make sense for this allocation. So basically, we take all these factors, and of course, so the bucket, of course, and the data type, right? Everything we have in the request, and when you take all these factors, you can make a really intelligent decision. So one way we did that was saying, well, we are experts. We can tell how to take this information, and make the best factors and make the right decision in the code. And that's good. We did it. And the thing we're doing on top of that is understanding we can do that in the future. What we want to do with that is take all these factors into a learning mechanism, right? Because we cannot predict what will be the important factors in future platforms. It could be that they're going to have a very low latency or very low network latency, right? You're going to have a way better performance for them. So by not providing an expert system for that, by providing a machine learning algorithm for that, you actually can create much better future predictions for your platforms. So that's how basically we pick the nodes we want to allocate for this chunk, right? So
does it reorganize blocks to figure out, okay, if I have a hot node and I have a warm node and a cold node, it reallocates blocks then?
Reallocate, you mean?
It reorganizes the blocks essentially to say, okay, I need all my hot stuff living inside of here.
Exactly. So you saw the example with the first part of a movie, right? Yeah. For example. Or you have a hot object, and objects being read more than others, right? So you can do the same allocations over and over time when you discover that.
No, you can do it, or the system will automatically detect that over time.
No, I'm saying with this information, I mean like this. This is the information we collect, and this is the information we have all the time when we have the allocation process running. And we run this allocation process when you write, when the write process works, and when we scrub the data as well. Okay?
Yeah, but you could write everything down. Maybe it hits 3 hosts, and all of a sudden those 3 hosts for that certain block, now they're not good data on the road. So you reallocate to make sure there's one hot inside of that.
I think Guy is giving you the gory details, but I think what is important to understand is we are trying to optimize to 3 main factors. And those main factors are, first and foremost, the resources that we have. And resources are all these traits that they can change over time, and they can change over time.
Yeah, so there's back-end processing that rebalances on a regular basis.
First of all, the nodes, is building the information and the knowledge about the resources that you have. This is the first step, okay? So now you have, okay, this is what I have on the battleground. Second point is the data that you're managing. Not all data behaves the same, and it can change over time. So, for example, you have an archiving tarball, huge one that you wrote to the system. You've not accessed it in maybe 2 months, but now you're reading it. So we already know that you're reading it, so we need to do something about that. Okay. So the second point is data, and the third point is locality. Who wrote what from where? Who reads what from where? Okay. So we have to cater to different workloads, like you write something here, but we already know, based on our experience, that the same data will be read from here in about 30 seconds. So we have to start to bring stuff up. So these are the 3 main factors that we look at in the data placement. And the data placement is not static. It starts with a certain assumption, but it changes over time. Why would it change? It would change because you introduce new nodes, because the nodes change over time simply by the capacity that they have is depleted because we're using it or another application. It could be that the use case or different applications are using it in different manner. So everything is dynamic. We look at all those traits and we move stuff around. Of course, there is some balance there. We're not trying to make it very noisy because then you get very little benefits, but this is part of the machine learning that we're going to introduce because we don't know what is the ideal. The ideal is what basically what the experience, and we're going to try to optimize to the experience rather than this number.
Is the data intelligence finite, or is it for the life of the data?
I didn't quite understand the question.
So when people are reading this particular file, this or that, is it going to collect history 30, 60, 90, maybe a year, and then cut it off at that point? Or the moment I write data, I'm going to collect analytics on that data and keep that history for the life of that data until it's purged?
No. It's an ongoing operation using heuristics about the behavior which is ongoing. Because as I said, you might have an archive that you've never touched, and then you simply
that's the reason I asked. We may have something that gets hit once a year, but it gets hit every year at that time.
And once it gets hit, usually most often than not, you would start once a data has been hit in the last whatever metrics it is, like an hour or day. most often than not, it will be hit again in the next hour or day. Okay, so we would accommodate to that, of course.
Can you set the time occurrence for the rebalance, or is that just all the time?
No.
Well, what we're doing tonight. So I'm describing the write file, right? But running the rebalance we're doing constantly,
Okay.
right? And we're trying to get that, throttle that correctly, as much as we can, because we don't think, someone will be possible to aim that really correctly. But if someone knows how to do that, would love to give it the option, I think, or learn how to do that better, right?
Most probable is where we won't give the option, because the less buttons and throttles you give to the admin, the better their life is.
Yeah.
Yes, they would say, we want more buttons, we want to control this, we want to control that. Then the learning curve gets too steep, and then they don't enjoy those. So
yeah, I look at it because you created a really interesting network problem. So that's where if you're rebalancing constantly, it adds that extra network overhead that I might not want inside of my world until a certain point of time.
I totally agree. So I think that, there are environments and there are use cases, let's take an extreme case. You're using very flaky nodes in a terrible network and you're bombarding it with data read and write. Maybe this is not the right solution. But for data centers with nodes which are stable, which has reasonable power and reasonable network, most often than not, that is not the case. We didn't see that.
And what we wanted to do actually is allow you to change the placement policy. We think that will be the change you want to make, right? You want to change that placement to be on another cloud or remove one of the spools, and you want that effect to happen, right? Mm-hmm. Because you made that change. So yeah, I agree with you that if you constantly have changes in your resources, that might be noisy. But if you actually make the change, you actually want the effect.
You have to think a little bit about the use cases that we're targeting too with scalable, low-cost object storage. It's things like 3-year retention of Splunk. And so what are the expectations for the performance SLA on that? Well, pretty low. It gives us lots of time to think about these problems like annual cyclicality, these corner cases, and how we would feed the machine learning algorithm. But it's the kinds of workloads that are being targeted for our 1.0 probably for the next year. The company are relatively static, relatively very consistent, long tail. It's hot at the beginning and cold over time, and rarely retrieved for analytics. And the performance SLA for that occasional retrieval is not a big deal. So I think we can imagine a million corner cases, but it's very clear that there are constraints that we have to obey related to bandwidth, and bandwidth has different costs at different parts of the network, and those are easy. Constraints about throttling bandwidth consumption over MPLS connections, et cetera. Those are pretty straightforward things to.
Let me go back for a second, just touching that. There's values in each of these possibilities. So the values that we're trying to achieve by respecting all these are basically to release all the platform lockdown that you would otherwise have if you designed your system to a certain capacity CPU and performance, right? And so platform will change. You will introduce new nodes, or a certain node you'll I don't know what make of it, right? So it will change over time, and you will introduce new nodes that behave very differently from what you had so far. So what we wanted to achieve is that this will be a factor in the allocation, so that if you have better nodes, you will get the better performance over time, and not stick with your old platform performance.
That's a major power play in my mind.
Exactly.
Because another object storage is how I have to build it. I have to build out a performance ring, a mid-performance ring, and a low performance ring, and I have no way to actually move my data unless I manually do it.
And that's about prediction. We don't want you to predict and say, okay, I'm going to build a system I'm going to use for 5 years, because you don't know how to build it, because you don't know how it's going to behave. Yeah. And we're saying let's take all these factors and calculate them into the allocation and into the placement. Do that in a smart way centrally, because that's not it's not a data path. You don't need to move your data here. You just need to make the decisions here. So that's a good place to do that, and all these considerations allow you to change platform over time and not lock down to a platform. And the other way is all your placement policies, right? So you can say, well, that's my cloud strategy today. I'm going to change my cloud strategy tomorrow, and I want my system to evolve, right? To make that effect. So that's the thing we want to implement in the allocation. And of course, this allocation I'm describing in the right path but we're doing the same thing when you actually go through data for rebalancing. Same thing. Going all the data, asking, well, is that the perfect way to put that right now? If not, well, we can change. Of course, we can throttle it down, decide how much movement is relevant in each time. But it makes sense to change, to evolve, right? And the last thing will be data. I mean, data behaves differently for different systems. So you might have data that, and over time, like I said before, right? If you start reading certain data, you want to restore a certain backup or a certain, whatever it is, Splunk archive, whatever it is. So it changes over time. You cannot really know if this is going to be hot or cold in next year. So you want to react to that. Okay? And let me give you some other things. So let's take this. So once this was allocated, let's show you how the writing is done because it's we have time?
How long do we have?
About 0 minutes.
0 minutes? Okay.
Right around there.
Okay.
So do it. So we write to the first node, then we replicate to the other nodes, and we replicate
Yes.
to the other.
So I'll give you the 0 minutes.
So I've got the read question, because if we've got 0 minutes,
Sure.
if I've got 13 copies, when I do a read, do you ask for all 13 copies and then use the first one that comes and waste the other 12 times of the bandwidth?
No.
No.
You know what we do? First of all, we try to pick the best one for this read because we have a lot of information about all these 13 nodes.
Okay, and
So we know
best-
availability,
and
we know
best is
performance.
fastest and closest?
Yeah, so we as cost effective as it can be. So if I can give you the best locality and the best performance and the one that's not overloaded, of course, so we can say how many requests we're actually redirecting to that node as well. So that's what we're inserting here. So load balancing.
Okay, how much do you know about network locality?
So what is that? The first step, I'll give you just a hint about that. First step we did already because it was easy and that was control the customers want, was to just tag these, so assign an endpoint to a pool. And that's an easy thing because you have usually endpoints in the same, infrastructure area or data center.
So you're assuming a pool is in a location.
So that's the easy one. That's a controlled way to do that. And the uncontrolled way to do that is give us the ability to find your topology and see that this is a higher latency network and this is a lower latency network, and just respect that. And just,
Okay, so you're just going to explore that and say.
Yes.
Okay, great.
If we can.
Perfect.
We're very short on time, and so I just want to highlight one point that was touched on that because we need your help, and this is the reality. What we say from a technical perspective is Noobaa is, as I said, provides an AWS S3-like that can take use of heterogeneous resources. And this is the key DNA for us, heterogeneous resources. And those could be different nodes, and they can change over time, et cetera, et cetera. The benefits are that platforms can change over time. You need to go to the cloud, et cetera, et cetera. So I hope that we've managed to provide with a highlight of what are the benefits of heterogeneous resources. Now, we need your help in helping us how to convey that to users, because we cannot have 2 hours this technical discussion with every user about the values of heterogeneity. Okay? And this is what we need help with is I hope that we were able to transport to you the values that you get or the benefits that you get out of a system that can handle heterogeneity. How would you say that to the customer? And we love your input.